Welcome back. In this video, we're going to solve valid parenthesis coding challenge. So let's understand what is the problem now. So valid parenthesis coding problem, the input will be given as a string of parentheses. Each open bracket should contain a closing bracket. Let's spend some more time in understanding the issue. What is the input? So on the screen, when I say valid parentheses, so these are the valid parentheses. Get this image. So for left bracket, so the right bracket is the valid closing. So the left curly, the right curly is the valid closing. For left square bracket, the right square bracket is the appropriate closing bracket. Let's see some of the inputs. So this is a valid parenthesis because it has one opening curly bracket and one. This is invalid because the first open curly bracket has a closing curly bracket, but the first square bracket doesn't have a valid closing. So this is invalid. The third one, if you see, set open, close, open, close, open, close. This is also valid. And this one, it's also valid. Open, closes here, open, closes here, then open, close, open, close. This is invalid because this has open and close, but the inner second and third characters, they are in reverse. So this is invalid. So let's understand how the stack is going to work. So this is the stack. So I'm going to put some items into the stack. So this item, here. So this is the first item which went inside the stack. Then the second item, the third item. So these are the three items I put it in the stack. The stack will work exactly reverse to the queue. So the stack last in, first out. So this is the first item which came inside, second item, and the third item. So this is the last item which came. So LIFO, last in, first out. So when you are working with stack and you're trying to remove the items from the stack, so the first item which goes away will be this one. And then the second item will be this one. And the third item will be this one. So let's see how this stack is going to work in our process resolving the valid parenthesis issue. So this is the input. So for every opening bracket, see the left set is a opening brackets and right set is the closing bracket. So I need to verify the string, each and every character, and if it's a opening bracket, I'm going to keep it in the stack. So the first character is the open curly bracket. I'll come here and I'll put it in the stack. So the next, and I'll remove it from here, or I'll move the pointer to the next character. And again, it's a open curly bracket. So I'll come to the stack and I'll put it in the second curly bracket. I need to the pointer. So now it's a opening normal bracket. I'll remove it from here. I'll come here and I'll put it in the stack. So now it's a closing normal bracket. So this time I will, since it is not a opening, so I'll read this and I'll go to the stack and I will read the last item. The stack will always pop. When you pop the stack, it will give the last in. So, and if they are compatible, that means if this is opening and this is closing, then you keep validating your string and removing this, removing the pop item. That means as of now, your string is valid parenthesis. So then again, you got the open square bracket, move it or move the pointer, put it here, then come here. This is a closing square bracket, validate, and both are valid. Keep doing. And now it's a closing curly bracket. Check the pop item. It's a curly open item, so they are valid. Then again, they are valid. Remove. So at the end of your execution, if both the stack is empty and you validated all the characters, then it's a valid parenthesis. So the input is valid. The input is having valid parenthesis. Let's see some invalid parenthesis also. The first character is open curly bracket. Remove it from here and put it here. And the second character is a it's a closing square bracket. And since it is a closing, keep it in the memory and try to check. So both are not compatible. This is square and this is parenthesis. So it's not valid parenthesis, and you can stop the execution here itself and return it's a invalid parenthesis. It has invalid parenthesis. Let's construct some logic. Valid the balanced parenthesis. So this method I'm going to return the string as using stack. For simplicity, you can return the Boolean value. Take put string. It's going to return some string. So first declare a stack. We are using the stack. Here, stack here. Stack of chars. So stack, and then for each character the input string. So now I'm going to check the first character. So let's put these stand. Here. Okay. So if the first character is the open bracket equal to open normal bracket, or equal to, so this should be in the single quotes, not the double quotes, because it's a character. So if it's a curly open bracket, or it's a curly square bracket. So what I'm going to do, I'm going to push into stack, push C. It's not a opening bracket and it's a closing bracket. Then else if C equal to closing normal bracket or C equal to a closing curly bracket or C equal to closing square bracket, then what I need to check. So if it's any one of these closing brackets, then I'm going to pick the um, char top read equal to stack dot peak. So this will give the item which we kept in the top. So the item which went into our stack, the top item. Now I'm going to check this C value with the top read. So if you can rename this, go to rename in all the places. So current string character, if current string character equal to the closing normal bracket, and so top read not equal to the respective opening bracket, then this is a invalid string. So what I'm going to return string. So the input string is having invalid parenthesis. So the current string character is a closing bracket, and the top read, the top item in the stack is not a opening bracket, then it's going to be a invalid string. Similarly, copy this and there will be or condition. So if it's a closing square bracket and if it's not a opening square bracket, then the same. And if the current character is closing curly bracket and if it's not a opening curly bracket, then it's a invalid string. The logic. And after this, I have to pop the item. So if this condition is not met, that means if the opening character, if the current string and the top read is matching, then I'm going to pop the stack. So that means that item is validated and we can continue validating the next characters. So if there are no issues and if we find everything one by one, and if we complete all the characters and then at the end, that means all the characters have been successfully iterated, and this for each loop will come out. So once you come out from this for each loop, now you have a condition to check. If stack dot count equal to 0, because we have to check if the last item is invalid, if the last item in the character is invalid and some of the characters in the stack item not popped out, then that means it's not a valid string. So if the count is 0 or not equal to 0, then it's having invalid parentheses. Or in the end, then return it's having valid or balanced. Sometimes same problem can be asked as, is it having a balanced parenthesis? Most of the code is ready. What I mean, we need to cover few edge cases. I'm going to show the edge cases, how they fail, but we will run this. There will be a couple of errors will be thrown and will give some undesired output. So let's see, and then add up the edge cases. So this is the input. So this is a valid string. This is a invalid string. This is again a invalid string. So let's see what our code is going to return. Run the code. Yeah, it's failing. It's throwing an exception. So let's see where it's throwing an exception. So it's throwing. So it's validated the valid string. So in the second string, it throwing some exception. So let's debug and see what is the edge case. I know the edge case, but I want to show you so that understand how to write the edge cases. The code. So the second input is throwing exception. I put a breakpoint here. Breakpoint here as well. Okay, so what is the input? So this is the input. Just so at the beginning, it has a closing bracket. So let's see where it is failing and what we have to do to cover it up. The first, it's not pushing into anything, the stack, because it's not a opening one, it's a closing one. And in the else condition, yes, it's one of the closing bracket. Then we are trying to peek the top. So there it fails because the stack is empty and it's going to throw an exception. So this is so to cover this, we have to add another condition. See what it's going to add. Before peek an item, so just check this condition. If stack dot count equal to 0, then that means you have an item to validate, but your stack is empty. You have a closing bracket to validate, but your stack is empty. But then return it's invalid. So invalid parentheses. Now test the code after adding the logic. See what is the output. Okay, so this is the output. So the first one is valid. The second input is invalid, and even the third input is invalid. So now we are covering all the edge cases and everything. But still, I would like to add one more edge case, which will reduce the unwanted checks. So in this case, so there is if the number of characters are even, that means here the number of characters are 8 for every opening bracket. So there is a respective closing bracket. So here the number of characters are 8, but here the number of characters are 7. So in this, the number of characters are 7. So when the number of characters are odd, we no need to check the entire string. The string itself is a invalid, it's having invalid parentheses. So when the number of characters in the string are odd, not even, then you no need to execute all of this code. And even you no need to initialize the stack, you no need to write the for each loop and all of this. So straight away, write a edge case and close the deal. So here is our edge case. So if the input string, if put string dot length percentile 2 is greater than 0, is not 0, then it's an invalid string straight away. If the length percentile equal to 0, or if the length of percentile equal to 0, then it's having even characters and you can further validate. Let's debug and see. Run the code. The first input thing is having 8 characters. So the percentile equal to 0, and then it's going to do a further check. And the second input string is again having invalid string, but it's a 8 characters, which is even odd. Yeah, so this is having 7 characters, and when you have odd number of characters, you no need to waste your time in executing all of this stuff. Just straight away return and close the program. That's it. So when you're writing the code interviews, addressing edge cases is very important. So the interviewer, he will get impressed to write the edge cases and highlight the edge cases. This logic everyone can write, but these edge cases always will save the program, save the time, save the resources. So try to improve your analysis on edge case and try to add as many as edge cases possible. Thank you for watching the video. The next video I'm going to explore one more approach for the valid parentheses or balanced parentheses. So I'm waiting for your feedback. Please watch the videos. Give me your feedback so that I can improve the quality and also suggest the topics you want to learn. Thank you. Happy coding.